As app developers, we love working on delighting our users with smart features and beautiful design and the kind of UX magic that makes you warm and fuzzy inside. But every now and then, our apps need to reach the outside world. And typically, we do that by contacting a server and using their APIs. So even though REST has been the golden standard for HTTP APIs for quite a while, developing and interfacing towards REST APIs is still quite a messy process sometimes. So what if I told you that you don't ever have to ask your backend developer again to shave off a few properties that you don't need, or to include a relationship in a JSON response, so you don't have to fetch and do another round trip to the server? And speaking of JSON, what if I told you you don't ever have to parse a single line of JSON again? Yeah, 20% off, of course. Well, this is the promise of GraphQL with Apollo. And if you can bear with me for this 30-40 minutes, I'm going to show how you can accomplish all of this and finally put REST in peace. So I'm Alek. You find me at Mr. Alek on Twitter. I also have a somewhat outdated blog at iOSnomad.com. Previously, I worked at a digital agency here in Stockholm called the Ape Group. But nowadays, I work at Doer. And we help small business owners with their bookkeeping and other administrative work so that they can focus on building their company. So if anybody of you here has a company, you can go to doer.com and try out our service. So at Doer, we've actually been using GraphQL for the past 6 months. And before moving over, we felt a lot of pain working with APIs. So we were using API Blueprint, which is this kind of markdown-based description format to communicate around our APIs between backend and front-end developers. So we had one repository with specs for how the API should look like. And whenever a change was to be made, it was proposed as a pull request to this blueprint files, so everybody could comment on it, and then it would get merged into the spec repo. A ticket in Jira would be created out of this pull request, so a backend developer could implement it into the real API. And this sounded great in theory, but it didn't actually work out for us. So we also had corresponding blueprint files in the actual backend repositories. So we always could see what was the actual current implementation, and that would generate docs. So you could always check them out. But as you might know, in a startup environment, priorities change quickly. And sometimes merge proposals in the spec repository never made it out to implementation. So after a while, this specification repo got infamously known as the wish list, because some of its changes never made it to production. Additionally, these blueprint files, they really required additional tooling to really become a contract for a data model. Without that kind of tooling, and if it wasn't configured properly, it would happen that suddenly the backend would send some unexpected data to the client, like you would receive a string instead of an integer, or you would receive a new enum case you hadn't seen before, which of course led to bugs. So all of this created unnecessary friction in our team between backend developers and front-end developers, because we really had a hard time syncing expectation with reality. So this led us into exploring GraphQL. So not only could we see that it would probably solve our problems, but also enable us to move faster on the client side. So how did GraphQL help us with all of this? Well, let me explain by showing you what GraphQL is all about, the core concepts, and then the Apollo iOS client that we use at Doer. Now, doesn't this bring back fond memories, this early screenshot? So let's go back to the history of GraphQL. Back in 2012, Facebook was about to make their newsfeed native in their iOS apps. And they looked at their existing REST APIs, and what they noticed was that their data model wasn't really flexible enough to give the clients the data it needed without doing multiple round trips or fetch a bunch of extra data that it had to throw away. This is, of course, wasting precious network and battery life. So they sat down, and this triggered the creation of GraphQL. So GraphQL is a query language for APIs. It's an alternative to using REST APIs. And if you look at a typical REST API, you have endpoints for different resources. These are different URL endpoints. And then you use the usual HTTP verbs like get, put, post, patch, and delete to fetch data and modify it. And typically you get a one-size-fits-all JSON file back for each endpoint. So you don't have much control as a client of what you're actually getting. So in GraphQL, instead, oh, that was laggy. But GraphQL instead exposes the entire possibilities of the data model through this one graph. And it's just one single endpoint. And instead, as a client, you make queries that traverse this graph, and you pick and choose what fields you want, and you can go into the relationships and get everything back as a single response. So this is what a query looks like. And as you can see, it's very similarly shaped to JSON. It's its own format. It's not JSON, but it looks very similar. So you start off with either a query, which reads data, or mutations. So mutations represent any kind of action that changes data. So like adding stuff to a list or deleting or updating objects. And they have a parallel graph to the query graph. Now, if we look at a response for this query, you can see that it almost one-to-one maps against the query. So it's very predictable. As you're writing the query, you know exactly what you're going to get back. So let's look at how this looks like in a real API. So GitHub just recently published their GraphQL API. So let's try and use that. So here's the GraphQL API. And they're actually using a tool called GraphQL. And GraphQL is it's usually dubbed as the killer app of GraphQL because it really shows the power and flexibility of GraphQL. So GraphQL actually, when you connect it to, yes, of course, sorry, let's make this window a bit smaller so I can zoom in on everything at once. Okay, so let's look at the query first, and yeah, let's look at everything. Sorry, is this good? Great. So what GraphQL does is that it makes an introspection query at the GraphQL endpoint, which basically you get back all of the fields, all of the objects, all of the relationship, and documentation of the entire API. So now we can have a look here with the Documentation Explorer. We can see what kinds of objects there are, and then we can type a query, execute, and you get data back. So it's super, super simple. It's a great way to explore APIs. So now let's take a more fun example. So instead of just listing my name, let's list organizations. You see that we get autocomplete right in the API. We can have a look at, oh yeah, this bug. So let's not worry about this. I can't scroll down here, so I can't actually go to the user. Maybe I can do that if I go through an organization first. See if there are any users here. Okay, let's skip the documentation then. So the organization's endpoint, or the organization's attribute, it's actually paginated. So we're going to ask for the first 10. And inside, since it's paginated, it holds a bunch of metadata around the relationship. But we just want the actual nodes, which are the organizations. So here we can take the name, execute, and bam, we get the organizations that I'm currently attached to. And that's Objective-C.io, Doer, and Cocoa Stockholm. And already now, if you imagine this being a REST API, you could see that this would most probably have to be done with several queries. First, maybe get the current user, get a bunch of IDs, then for each ID of the organization, get the name. And we can take it even further by looking at repositories. Let's pick the first 2. The nodes, once again, because we want the repository objects, not the metadata, and the name. And now, for each organization, we get the first two repositories, which is really cool, right? Super, super simple to use. All right, so that's queries. Great, it worked. So if you paid close attention, you also might have seen that this was all made type safe. If you looked at the documentation, every single attribute had a type. And this is great for us as Swift developers because we hate working with untyped stuff because we never know what to expect, right? And the type system in GraphQL is actually pretty sophisticated. So not only do you have the usual primitives like ints and floats and bools and strings, you can also make properties required, so they can be non-optionals in Swift. You can implement custom scalars. So for instance, if you want to send the dates, instead of just sending strings, you can define a new type called date and let it be a custom string, but then in the client and in the documentation, you know it's going to be a date. It doesn't just say that the attribute is of type string. And this is really useful for stuff like dates and currencies and other stuff. There's also interfaces which correspond to Swift protocols, and there are union types, which is super useful for things like search. So for instance, at Doer, we implemented app-wide or service-wide search. I think it took us 2 days. And basically, we would query and then get back this union type of every single different kind of search result, which makes you able to just switch on the type and you still get the full type-safe object back. So you don't have to check if this and this property are of this kind, then this is perhaps this kind of object. Everything is type-safe all the way through. So in short, GraphQL exposes all the capabilities of the server at once to you in a graph, which means that when you're designing APIs, you don't have to do any guesswork on what the API needs. You just present everything that's possible. And really, what we noticed that we could, since the schema that you write GraphQL in is so readable, we can just use that as a format for discussing the spec as we were building it. So instead of having a separate markdown format, we could now, both backend and frontend developers could look at this schema in pull requests, and it will actually become the implementation. So we don't have that disparity anymore. And of course, we get type safety. So we said that Facebook had come out with this already in 2012. That's 5 years ago. How come we aren't using this already? Well, so Facebook open sourced GraphQL first in 2015, and it did so as a spec together with a reference implementation. And even though the original implementation was for a native iOS app, the reference implementation when they open source was in JavaScript. So of course, this is no good for us as native app developers. So enter Apollo. Apollo is a set of tools, client libraries, and a server that the team behind Meteor has made. And I think they started out right after the spec got out on GraphQL. And nowadays, they actually have a Swift framework, which we use at Doer. So if you look at Apollo for iOS, it actually consists of the client framework, which handles all the communication with the server. You also have a code gen tool, which gives you query validation. So as you're writing the queries, you can have a build step that validates your GraphQL query against the server before you even build the app. And it generates type-safe Swift structs. So you never have to parse a single line in JSON again. And everything is type-safe, which is awesome. And then the final thing is that they have an Xcode plugin for syntax highlighting of GraphQL queries. So now let's look at this. And let's make an app out of the GitHub API. All right, this should be big enough, right? Great. I can see that I've already lost syntax highlighting. Oh, now it's back. Great. Okay, so here I got a super simple sample project set up with Apollo. If you look here at the file list, you can see that I've included a github.json. This is actually the full GitHub API as returned by this introspection query. And there are scripts included with Apollo for running this towards the server, so you can get the full schema of the API back. Then we have .graphql files, and this is where you're storing your queries and your mutations. And together with Apollo CodeGen, every time you make a change to your .graphql files in your project, the code is automatically evaluated, and all the Swift code gets auto-generated, and your queries get validated against the schema. And they all end up in this auto-generated file. So a typical workflow that I like to use is that I use GraphQL, and then once I get the data I want and I got a nice query, I just copy-paste that query into my Swift code. So let's try out this first simplest example we had. Just get the current viewer's name. We execute it. We see that, yep, it's getting my name. Great. So let's copy it. Put it in our .graphql file. You see that we get syntax highlighting. And let's build. Oh, yeah. So you have to name your queries, because otherwise you can't reference them later. So let's call this my name. Great. Now we can have a look at what Apollo generated for us. So this was generated. We can see that we have a class called myNameQuery, which includes the query that we typed in. And down here, we have a data struct, which contains the viewer object, and the viewer object contains the name. And here we have all the parsing code, so we don't have to write it ourselves. Now let's use it inside our app. So here I got the view controller set up, and it's got the Apollo client. It's super simple to configure. Here for the GitHub API, we have to provide an authentication token, So I'm giving it to the URL session configuration. Then we have the API URL, and then we just construct the client. So now we can do apollo.fetch my name query. It doesn't take any parameters, so we can just give it an instance like this. And then we also have a completion block where we get result and errors. So let's first just see that this works and print out the result data viewer name. Let's see how this goes. Great, we got the name. We didn't have to do any JSON parsing at all. Okay, so in our app, we have a table view. So my thinking was that, okay, let's maybe do an app where you can see all your favorited repositories, and let's list who's the author, what the name of the repository is, and how many stars we have at that repository in total, together with the profile picture. That should be simple enough. So let's go back to GraphQL and construct this query. So now, instead of the viewer name, we want the starred repositories. Repositories the user has starred. Great. Let's get the first 10. So on the relationship, you have stuff like the total count, which you can fetch, but we just want to get the actual edges, or nodes actually, which are the repositories. So let's list the repository name. So what was the author? On a repository, we have owner. Great. So we fetch the owner. And if you look at the owner, we have an avatar URL. It has an optional size parameter, but let's skip that. And we get the login, which is the username. So let's run this. Okay, well, this looks good enough, I think. We get the avatar URL here, get the name of the repository, name of the owner. Let's just double check that it's the actual query I wanted to run. Oh yeah, we also wanted the number of stars. So on each repository, we have a relationship called Stargazers, which is a really cool name, right? And so the Stargazers is basically all the users who have starred this repository. But in this case, oh no, it's not on the owner, it's down here. This time we don't want to fetch the actual Stargazers. We just want to fetch the total count of everybody. Now let's run this. Yep, we get it back. Beautiful. So let's copy that in. Go back to Xcode. Go back to our GraphQL file. Paste it in. Build. Oh, name. Always forget naming the query. So we should name it, what was the name I was using for? My star repositories. Sounds great. Great. And now we can have a look at the generated code. We see that there's a new class, my star repositories. And we have all the data. It's all here. Great. So now let's just build the app. Fortunately enough, I have a couple of code snippets. So we're going to make a type alias. So one little nuisance is that Apollo, in the generated code, it creates a lot of types within types within types. So usually I create type aliases for this. So here we have the query data viewer star repositories node, which is the actual repository. Let's create a variable here. when the repositories change, we load the data. And this is a horrible table view implementation. Please don't look at it too much. But we just return the count of the repositories for a number of rows, configure a cell, and this thing you should never ever do in production. But here we load the profile image on the main thread synchronously, so it's going to block all UI. Yeah, I know. I'm a horrible person. And then let's fetch it. So, okay. So as you can see, when we fetch, it's super simple. We just check. Okay, did we actually get any data? We dispatch to the main queue, and so the GitHub API. In the GitHub API, every repository you get back here is actually optional. So we want to just flat map that out. If you wanted, you could like show empty cells with like an error string or something for those repositories that couldn't be fetched, but let's skip that. And I think this should actually be it. So let's run and hope the demo gods are with us. Come on. Hey, right enough. We have everything here. Now, if you look at this table view and look at each cell, can you imagine building this with a REST API, with a traditional GitHub REST API? You would probably have had to do multiple round trips per cell, which would have been awful for performance. But with GraphQL, we just make one single query and we get exactly what we want back and no extra bloat. Okay, so I'm sure there's a lot of people who are like, okay, so what are the bad sides of this? So this slide is for you. So basically, for us, Apollo is still a very new project. And I would say that if you want to use it, you should expect that you're going to find some kinks that haven't really been solved yet for your application. So expect to fork the different repositories and please contribute back. So one thing, for instance, is that there is no multi-part file upload support yet. There is a proposal up, and at Doer we've actually implemented both on the client and the server against this proposal, but we haven't had the time to package it up to contribute back yet. Also, we've seen some problems, or not problems, but it has been hard for us to debug the GraphQL server. Sometimes it can get you some weird errors back as a client. And also the Apollo iOS client in itself moves really fast. So currently, for instance, the current latest version is in beta. I think it's 0.6, which completely rehauls the caching system, and it uses SQLite. So expect that things will change, right? But the big question is, though, is it ready for production? And I would say an astounding yes. So we have been working with it for the past months, and we've had it in production for, I think, 2-3 months, something like that now. And I was really excited to give this talk about GraphQL, because ever since we moved, I can't really see how I could go back to REST APIs. And I really believe that as REST was an evolutionary step over the old SOAP APIs we had way back that I hope nobody had to ever work with, I really believe that GraphQL is the next step in this evolution. And it doesn't really matter if you're working with iOS or Android or web development or even on the server. There are just so many benefits towards this way of working. Some learnings we've had after doing this. It's awesome not writing JSON parsing code. We also noticed that the API design process really became democratized in a profound way, because now everybody can look at the pull requests that get into the GraphQL service, and since the schema definition language is pretty simple. Anybody can review it. And Apollo is itself, it's pretty simple to work with. So as a client developer, you can easily just like add a generated property. So for instance, if you have a user with a first name and last name, but you might want a display name, and you don't want to duplicate logic of concatenating these strings, and maybe in some cases you should do something different, you can just add it on the GraphQL server end, and it's actually really easy to do. Another thing is that deprecations is much easier to work with. You can deprecate individual attributes, and you just document them as deprecated, and then they're going to show up as deprecated in the GraphQL documentation. And it's really easy to just, for instance, if you've implemented the wrong type, you just add a new property, and then you let the old property just route to the new one and maybe have a sensible default value instead of having to bump the entire endpoint. And since it's so easy, you can actually do stuff like mocking on the actual server when you create new features for all of your clients at once, and you don't want to have this staggered planning where the backend has to do everything, and then the clients have to sit idle and wait while their timeline is shrinking. So instead, you could like use feature flags and just put up a simple GraphQL mocked API, and then both backend and client can much more quickly iterate on the tiny subtleties of the API. Also, it's super simple to start really small. At Doer, we haven't yet converted everything, all of our APIs to GraphQL. But slowly but steady, we're getting there. And there's no problem with letting your app communicate both with traditional REST endpoints and with the GraphQL endpoints. It actually works really well. So if you're interested and you want to check out some more, I suggest you go to graphql.org and to apollodata.com. Apollo has some great stuff on their GitHub organization. They also do a lot of community talks, so they have a YouTube channel for that. If you thought I was just rambling too much, or you want to watch somebody else speak about basically the same thing, you can check out Summer Panard's talk at Swift Summit a couple of months ago. Another tip is GraphQL IDE, which is a tool built on top of GraphiQL, which we used in demo, which is basically kind of like Postman, which extends GraphiQL with collections of queries and multiple environments and stuff like that. And there's also an awesome GraphQL repo on GitHub, which contains a list of tools and websites and resources. So, of course, as everybody else, Doer is hiring. So if you want to work on revolutionizing an industry together with great people and want to work with cool cutting-edge technologies like GraphQL, just give anybody else a ping. Robin is also here tonight. He's working with us as well. So come talk to us. And thank you.
Okay, you got me sold, but how do I sell the backend developers?
How do you sell to backend developers?
Yeah, since we work in this like enormous team and we have like distributed multiple backends, I'm 100% sure it's going to be hard. How did you sell to your backend developers? To simplify the question.
Well, basically, we were actually moving over from a monolithical to a microservice architecture. So GraphQL worked really well because then they would have a common interface. But even if you're not doing that, if you have a GraphQL facade, it makes it so if you ever have any bugs in your backend which lead to like malformed data sipping out, the GraphQL facade is gonna stop that because it's type safe. So as a backend developer, you get feedback on what might be wrong in your code much quicker than if a client reports, this weird behavior, I'm getting this wrong value here. You can get it instantly. Of course.
Hi, you're a poll right now. Hey, have you noticed any performance differences between the GraphQL queries and the traditional Rust queries you were making before?
Well, so performance is somewhat of a complex topic, right?
Of course. I'm thinking mostly in like terms of response time from the server.
Yeah. So the actual GraphQL service is really lightweight. That's not going to add much to your response time. But it really depends on how heavy your REST endpoints, the existing ones, already are. Because if you for one object might have to do a lot of computation for some fields, or if you're joining in a bunch of tables and maybe sometimes the client isn't even interested in those attributes, then you can increase performance by a lot, right? And so Apollo has this tool called Optics, from where you can see like what's your most hit attributes, what are clients retrieving, and so forth. So I'd say you have a bigger chance of getting great performance with GraphQL.
There's one thing that is kind of cool with GraphQL. You can also parallelize different queries. So if it's a sync, then I don't know, is your backend JavaScript then?
Yes. So
okay.
The thing is, we're using Apollo's GraphQL server as a facade. So it routes to our other services. So, but yeah, as you were saying, you can parallelize. So if you have a query that fetches a lot of different objects on the GraphQL layer, you can parallelize all of that, even though you might run like a Python monolith, which is serial by its nature.
So that's related to that. There is a similar way to run like the famous SQL injection drop all or drop table. It's possible to send a GraphQL query that will kill all your endpoints. So do you actually guard against it? And I also see one of the downsides of the GraphQL, we've been using it also for a couple of years now, actually from the very beta, is that the bleeding edge on the server side is usually comes to JavaScript first.
Yes.
So if you love Node, then it's great. But like Java is probably the next best. But if you're writing Python, Go, everything else, those server sides are a bit lagging as well. So yeah, that's like a downside. But then yeah, do you guard against like those performance heavy queries?
So I'm not involved in building the actual GraphQL backend, but but I believe we do. I don't think we do any safeguarding yet, but we might. I'm unsure, but we do some like optimizations. For instance, when you fetch relationships, and we do stuff like if you don't only fetch the ID, for instance. We don't go ahead and fetch everything. We just fetch that foreign key. So we do a bit of introspection on the queries. And I'm sure there's a lot of more performance tweaks that our backend developers has done, but I don't have detail on that.
Regarding performances again, you mentioned something at the beginning that when you are mutating values, then you can have a parallel graph.
Yes, exactly.
Regarding memory or anything, I mean, do you mean that you're duplicating things? Or?
No, what I mean is that if we have a look at this slide, so this is the graph of all the queries you can make, right? And for mutations, there is another graph that looks just like this. And then, so if you have like you would maybe have a add comment mutation. Then you would go to like user mutations, repository mutations, issue mutations, add comment mutation. And then when you execute the mutation, what you get back is an entry point inside the query graph. So you might get an entry point here for the comment you just created.
Thank you.
No, we're not using subscriptions yet. I think So I haven't explored it super much on Apollo for iOS, but I think it's pretty early in that project yet. But of course, it's something we're going to look at later. But we didn't have that many like socket APIs before we did the switch either, so it hasn't been a priority for us yet. Yes, so there's this third thing, which is subscriptions, where so using sockets would be an implementation of subscriptions, where you could subscribe to a point in the query graph, subscribe for like the comments, for instance, and then you would get callbacks when new comments are made.
Your socket is always open, basically, between the two.
Well, that depends on the implementation then.
Because I just had a kind of a visionary thing going on here, because Gabriel was showing the Swift backend where you could have all the model classes there and make objects. What if we could just send those objects directly through a socket to our front end code and just have the objects there without doing any of these?
Yeah.
Side, you have sockets.
Well, maybe you two should go to a bar.
Maybe you could just send.
I think you guys should talk. We're running out of time, or actually the time is already out. I think I even was a bit over, but thanks so much for coming and thanks so much for having me.